Hello everyone, I'm Jesse Mason, and in this edition of Teach Me, we take a look at the principle of conservation of linear momentum as it applies to a perfectly inelastic collision. Now with all collision problems, we want to start by drawing before and after pictures. So before we have, well, it looks like a red fish moving to the right at 2 meters per second. We'll give that red fish a mass of 5 kilograms. And we have a blue fish moving to the left, a half-kilogram bluefish, with a speed of 10 meters per second. Now I said we were analyzing a perfectly inelastic collision, and in perfectly inelastic collisions, bodies collide and stick. So what's the velocity of these bodies after the collision? Well, the first thing we want to do is start by drawing a coordinate system for our problem. So I'm going to assign the positive x direction to be to the right, and just to make it look more like a coordinate system, I'll include the y direction as well. Not that we're going to need it. Now these two bodies do not exchange matter with their surroundings. That means they constitute what we call in physics a closed system. Additionally, we're going to assume that there are no net external forces like viscous drag acting on these bodies. And that means we can apply the principle of conservation of linear momentum, or Polcom. Polcom states that in the absence of a net external force, the momentum for a closed system of bodies remains constant, or is conserved. And we can state Polcom mathematically by saying this system's total momentum before the collision is equal to its total momentum after the collision. By the way, we can't use POCO, the principle of conservation of energy, to solve this problem, because the kinetic energy in a perfectly inelastic collision is not conserved. Some of that kinetic energy during the collision is transformed into internal energy. So of course we're going to use Polcom to solve this problem. So I'm going to write P before is equal to P after. And you'll recall that momentum is just the product of mass and velocity. So I'm going to start by writing the mass of the redfish times the velocity of the redfish before plus the mass of the bluefish times the velocity of the bluefish before equals, and now we're going to sum the momentums after, the mass of the redfish times the velocity of the redfish after the collision plus the mass of the bluefish inside the redfish times the velocity of the bluefish after. Next, we're going to note that here we're dealing with a perfectly inelastic collision. In a perfectly inelastic collision, the body's post-collision velocities are the same. They've got to be. They're stuck together. So what I'm going to do is rewrite this equation with VA in place of both post-collision velocities. I'm also going to factor out VA in order to make this equation a little easier to solve. So dividing both sides by mr plus mb, we're left with an equation which describes the post-collision velocity for two bodies undergoing a perfectly inelastic collision. Next we insert our initial conditions. I have 5 kilograms times 2 meters per second for the red fish, and 1/2 kilogram times 10 meters per second for the blue fish, divided by 5 kilograms plus 1/2 kilogram. So we get the velocity of the two fish after the collision is equal to 2.7 meters per second. 2.7? Hold on a second. Nope. Calculator says 2.7. But it's not possible for the velocity after the collision to be greater than it was before. I see our mistake. We defined the direction to the right to be positive. The bluefish is moving to the left, so its velocity needs to be written as negative 10 meters per second. So, inserting our values into the equation, we get 0.909 meters per second. Way better. This makes much more physical sense. The red fish slows down after colliding with the bluefish, just like it should. So there you have it, applying the principle of conservation of linear momentum to a collision, in our case, a perfectly inelastic collision. I'm Jesse Mason. I hope this video was helpful to you, and until next time, happy learning.